Hi, my name is Madison Griffin, and my presentation is on carbon sequestration. A lot of folks think sequestering carbon is a recent phenomenon brought on in reaction to our overuse of fossil fuels, but carbon sequestration is a natural process in which the Earth absorbs carbon dioxide. A balanced carbon cycle would be one in which the Earth was absorbing as much carbon dioxide as it was producing. But the use of fossil fuels and increasing issues such as deforestation have reduced the Earth's ability to sequester carbon. And here's a little something from an introduction to global carbon cycle management and carbon sequestration and its role in the global carbon cycle. A bit of a mouthful. It was a really good, fairly accessible resource for me. According to them, atmospheric carbon dioxide is one-third higher than it was in the 1800s and much higher than it was in pre-industrial times. Before we get started, I think it would be useful to define a couple of the terms that are going to be coming up. Carbon dioxide, pretty obvious one. It's a greenhouse gas that absorbs infrared radiation. The increase in atmospheric carbon dioxide, which is retaining this infrared radiation, has led to higher temperatures in Earth's atmosphere, and this is commonly referred to as global warming. Carbon sequestration, so this is according to the Encyclopedia Britannica, refers to the long-term storage of carbon in plants, soils, geologic formations, and the ocean. It's a natural part of the carbon cycle, which is pictured here. However, with the increase in anthropogenic or human activities, like the burning of fossil fuels, more carbon dioxide is being released into the atmosphere than can be absorbed through this naturally occurring process. More deliberate carbon sequestration is being considered to combat the environmental impacts of our carbon dioxide emissions, and this is referred to as carbon capture and storage, or CCS technology. Carbon sinks, another good term to know. These refer to reservoirs that retain carbon and keep it from entering Earth's atmosphere. Natural examples include plants, soil is the largest one on land, and the ocean is the largest one on the planet. An issue that's been brought up recently is ocean acidification, and this is happening because our activities have been basically our CO2 emissions have been mostly absorbed in the ocean, and it's at the point where it's not sustainable. In deliberate sequestration practices, compressed carbon dioxide can be stored in dry oil and natural gas wells as well, deep saline formations, and the deep ocean. So there are several methods of sequestering carbon. The first one I'm going to talk about is terrestrial carbon sequestration, also called biological or ecological carbon sequestration. So this method has some limits already. So by the rate of plant growth, as well as the available land. Another issue is that the only data showing significant gains in carbon storage involve these sequestration activities being highly incentivized economically. Some of these activities could include afforestation, planting forests where there haven't been any, reforestation, so replanting forests that have been cut down, and better land and soil management practices, which involve carbon farming and better agricultural practices so soil isn't eroded and can better sequester the carbon there. So historical deforestation has resulted in the loss of 20% of the world's forests and 10% of the world's carbon storage. According to the Encyclopedia Britannica, terrestrial carbon sequestration accounts for the absorption of 2.6 gigatons of carbon dioxide per year, which is not insignificant. The next method of sequestering carbon I want to talk about, and I'll spend a little more time on it because it's by us often. So, geologic sequestration. So, this is a technological approach of injecting captured carbon dioxide, which is caught in the production of fossil fuels like coal, back into the ground into porous rocks, usually. So, the effectiveness of this technique really depends on how much can be injected into the ground, how long the captured carbon dioxide will stay in the ground, as well as any negative environmental effects of this practice. This, at this point, it's not being done a lot, so only a few million metric tons are sequestered per year using this method. It's not very economical at this point. Uh, so energy-wise, so power plants using carbon capture and storage, CCS, require between 10 to 40% more energy than power plants without CCS. And this is because the carbon dioxide has to be extracted from other industry byproducts like flue gas and coal gasification. So when the carbon dioxide is compressed after it's been separated from these other byproducts, um, they have to ready it for transport and then injection. So the compressed carbon dioxide is less dense than groundwater, so you have to be careful where you inject it. After it's injected, it will rise up until it hits a what's called a seal. So people do like using dry oil and natural gas wells because these tend to have a natural seal. Some of the compressed CO2 will be trapped here, much like the natural gas and oil had been, though some will make its way through leakage pathways. Some are going to be naturally occurring cracks, and some will have been created when the fluid was injected in the first place. So let's see. Another issue is that this compressed CO2 can dissolve in groundwater, or it can change chemically when reacting to certain rocks or microbes. Physical trapping is an immediate concern, making this also, again, not economical. So it has to be monitored for decades or even hundreds of years to make sure it's not leaking. And then after that, you do have chemical changes that are going to occur in the long term over hundreds or thousands of years that you'll also have to consider. The potential carbon storage capacity is limited by the volume of compressed CO2 because even the compressed CO2 is much greater volume-wise than the fossil fuels that have been extracted by several times. So you can't just replace the fossil fuels with the CO2 emissions. There's more CO2 emissions than there were fossil fuels volume-wise. There are also some environmental risks, seismic disturbances, so earthquakes, deformation of the land's surface, contamination of potable water supplies, as well as adverse effects on the environment and human health. The next sequestration method, oceanic sequestration. This does occur naturally with a chemical reaction between atmospheric carbon dioxide and the ocean surface, though there have been some man-made studies looking at putting compressed CO2 into the deep ocean or below the ocean floor. The ocean is the primary carbon sink for anthropogenic carbon dioxide emissions. According to the Encyclopedia Britannica, 45% of our emissions remain in the atmosphere, 30% are absorbed by the ocean, and the rest is absorbed through terrestrial sequestration. The ocean currently absorbs 2 gigatons of carbon per year. We are having an issue with ocean acidification since we do depend on oceanic sequestration so much. And this is working to deplete fragile ocean ecosystems and deplete fish and crustacean populations. The last method of sequestering carbon I'm going to talk about is geochemical sequestration. This occurs naturally when carbon in dead plants and animals is compressed and heated over time to create minerals such as limestone, as well as what we know as fossil fuels like coal. Some scientists are considering the possibility of deliberately accelerating this process of weathering and burial so that we can sequester our CO2 emissions in a much more stable manner. A major issue with this method is first that the research is in its infancy. It also costs a lot, and even though it's looking to accelerate this process, it's still a slow rate of reaction, so it's not showing the immediate results we need. So I'm not going to focus on the entire history of carbon sequestration. It's been happening since life has been on this planet. So I'm going to focus on our efforts in recent years. Starting in the 1940s and 50s, scientists were starting to notice the unsustainability of our energy, such as our fossil fuel industry. In a 1957 article, a scientist said, human beings are now carrying out a large scale geophysical experiment of a kind that could not have happened in the past nor be reproduced in the future. Within a few centuries, we are returning to the atmosphere and oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years. This experiment, if adequately documented, may yield a far-reaching insight into the processes determining weather and climate, or as we know it today, climate change. I'm going to jump to the 1980s. So in the 1970s, we did have a lot of environmental efforts going on, but carbon sequestration really wasn't part of the talk yet. But in 1988, the Intergovernmental Panel on Climate Change, also known as IPCC, was established by the UN. It determines, assembles, analyzes, and distributes reports on the impacts and possible responses to climate change. They have developed standards of practice for measuring carbon sequestration since. In 1992, the Energy Policy Act establishes the voluntary reporting of greenhouse gases program, which allows industries as well as individuals to monitor their emissions and their attempts to reduce them. In 1997, the Kyoto Protocol in Japan becomes the first international agreement mandating reductions in greenhouse emissions. It wasn't ratified until 2005, though. So it required industrialized countries to reduce their emissions by 5.2%. It also incentivized terrestrial carbon sequestration, giving countries credits for afforestation, reforestation, and improved agricultural and land use practice. That's according to the Encyclopedia Britannica. In 2003, George W. Bush initiates the Future Gen Carbon Capture and Sequestration Project. So there was a lot of potential with this. It would have created the world's first coal-fired power plant with carbon capture technology, as well as integrating coal gasification with it. The compressed CO2 would have been stored in an underground saline formation, and the hydrogen that was produced would have been used to create electricity. But because of the high cost and for other reasons, the project was abandoned by 2008. Put this in 2007, Al Gore, as well as IPCC, earned the Nobel Peace Prize for their work in disseminating knowledge about man-made. 2009, 9, we have the American Recovery and Reinvestment Act, $1 billion to the development of technology through Future Gen 2.0. It's brought up in the Obama administration. So this one uses oxygen combustion. This is a little more efficient, and it becomes the U.S. Department of Energy's most. The goal of the project is to capture 90% of industrial carbon emissions each site that it's employed at. However, the cost of carbon sequestration at coal cheapness of natural gas to increase domestic might encourage the development of more natural gas, roughly half per unit of electricity coal-fired. So in 2012, and this has really been in the news more recently, but Iceland started a study in which they injected heat underground into porous basalt. The chemical reaction, the process of the storage was accelerated, and it converted 95% CO2 into calcite implications. One of the issues need for the long-term storage monitoring, which makes the CCS, the Paris Climate Conference team, we have a lot going on as well. So the first commercial, but the largest one in the world is going to be opening by the end of this. And this one was opened by NRG, paired with, and they retrofitted. Also this year, a bill was introduced in Congress, tax expected to be ratified by the end of. I thought I'd end this presentation by looking at the future of carbon sequestration. So in 2007, the U.S. Climate Change Science Program finds that deliberate and natural carbon sequestration will be necessary in future efforts to reduce atmospheric carbon dioxide, but it alone will be insufficient to control CO2 levels, which means that it will have to be done in addition to switching to carbon neutral energy sources, and also in addition to reducing our overall demand for energy, which would be a big change. The findings say that we would have to reduce our expected emissions by 75% to stabilize the carbon dioxide in our atmosphere to 550 parts per billion, which is 45% higher than it was at the time of the study in 2007, and twice the amount of atmospheric carbon dioxide that would be found in the pre-industrial atmosphere. IPCCs also kind of looking ahead. They estimate that the cost of electricity will go up because of the CCS technology is so expensive. So they estimate that cost to go up from 1 to 5 cents per kilowatt hour, depending on the fuel technology location. As we mentioned, like coal-fired plants produce more CO2 emissions, so the cost would be a little more inhibitive. So the leakage of carbon from reservoirs is also a concern in their reports, but it is estimated that properly managed geological storage would retain 99% of the sequestered carbon dioxide for over 1,000 years, and this is according to the Encyclopedia Britannica, which is pretty nice. So a 2016 study, so just recently, from the University of California at Irvine, shows that IPCC's estimates of soil's potential for carbon sequestration have been overestimated by as much as 40%, and this was an article in The Guardian. Carbon that is currently sequestered in soil is more than 6 times older than the IPCC's original estimates, and this means that it takes much longer for soil to sequester carbon than we previously estimated. This is important because soil is the largest carbon sink for terrestrial carbon sequestration, so more so than forests, for instance. So the study shows a big difference in the viability of terrestrial carbon sequestration as a short-term solution to deal with atmospheric carbon dioxide emissions. This also places more emphasis on as yet uncreated geochemical and other carbon sequestration technologies in order to keep the global temperature increase below the 2 degrees that the Paris Climate Agreement has just set. So it's a pretty important finding. But overall, the so carbon sequestration, the technology is in its early stages. The cost of CCS technology, not currently economical, and no one knows who should be responsible for monitoring carbon storage sites, whether it should be the companies, whether it should be government regulated, and this has to be regulated for decades, maybe hundreds of years. So this is something that it's a big question and a um, big cost. So that is my presentation on carbon sequestration. It's going to play an important role in the coming decades when it comes to um, reducing our CO2 emissions. But as the climate change science program finds, it's going to have to be paired with other things. It's not a big band-aid for the fossil fuel industry to use so that we can basically save the planet but have our cars too. So I hope you enjoyed the presentation. Here are a look at my references.